An angle is a measure of openness between two sides that meet at a point called a vertex. So if I have two sides, this right here is the vertex right here. And the openness between those two sides, that's the angle. Now, of course, these sides can be, line segments. They can be rays, so they go off indefinitely in those directions. They can be lines where, they go off in both directions. This. So this is an angle right there. Parts of a shape, which would be the line segments, that kind of idea. Now, angles are measured in two different units. Degrees, which is kind of the non-mathematical way of measuring it, and then radians, which is the nice mathematical way, though it's a little bit harder to work with. So technically, angles do not have units, and radians reflects that. Degrees does not. So we only have units for them, radians or degrees, to make them, obvious what we're talking about. So if you ever see the word radians or rad after a number, then you know it's an angle that you have there. Now, unknown angles, they're not given the normal variable names like x, y, or z. They're typically given Greek letters, alpha, beta, gamma, and so on. Or you're going to see uppercase letters. And the uppercase ones tend to name the vertices. So like this would be A, B, and C, that kind of thing. But they can also stand for the angle measurement on the inside. This is alpha here, this one's beta, any of those things work. Now, angles have different kind of names or different classifications, if you will. The first one is anything less than 90 degrees. It is an acute angle. It's always going to be less than 90 degrees, 0 to 90. Not equal to 90, because equal to 90, these are special ones for a lot of reasons why equal to 90 degrees is a nice angle to work with. These are called right angles. If they're between 90 and 180 degrees, these are called obtuse. And if they're equal to 180 degrees, well, equal to 180 degrees is if you take a point right here and you measure this angle, it's just a straight line. And that's why we call them straight angles. Everything else is really not classified beyond this because if you were to go above 80 degrees, so for instance, if I had an angle like this, really what you have is an obtuse angle here. So this angle is obtuse. This one just happens to be more than straight. So now in a full circle, there's always 360 degrees. And this is the same thing as 2 pi radians. 2 pi, of course, is approximately 6.28. And we can use that fact to create a unit conversion. 2 pi, you can say 2 pi equals 360 degrees. And you can put it as a fraction like this, 2 pi over 360. Of course, we can reduce by 2. And this is really the unit conversion you're going to be working with. Pi radians over 180 degrees or 180 degrees over pi radians. It depends on which way you're going. You always want the one that you're going from on bottom. So here we have 15 degrees. I'm going to multiply by 15. 15 over 1 is the same thing. By 180 on bottom. That way the units cancel of degrees and you're left with radians. And you can see, of course, 15 reduces with 180. That becomes 1. That becomes 12. And we get 1 times pi is pi. 1 times 12 is 12. Pi over 12 radians, which equals 0.2618 approximately radians. Likewise, if we had 3 pi over 2 radians, what is this in degrees? Well, you're going to multiply by pi radians on bottom. That way the radians cancel. This one should have radians on top. Those will cancel. And now you can reduce the pi and then simplify. 180 becomes 90, with 2 becoming 1. 3 times 90 is 270 degrees. Now, we tend to write radians not like this, because that is always going to be approximate. Pi is an irrational number. You cannot write anything multiplying pi as a rational number or as an integer. It's always going to be this irrational number. And what we want to do is have a simpler way than having to write approximately this. And the simpler way is just to leave it as pi over 12 radians. This is an exact representation. So this is what we tend to want to write, is pi over 12 or 3 pi over 2 in this case. You wouldn't write, whatever that is when you type it in a calculator to figure out the approximation. No, just write 3 pi over 2, and that gives you exactly what you need. So, like I said, leave it as pi over 12 radians instead of 0.2618 radians. Okay, give it a try in numbers 2 and 3. Now, on the coordinate system, angles are always starting on the positive x-axis here, and they go counterclockwise. This is an important thing to remember in mathematics. This is the angle you're looking at here. Now, on the actual thing, so on this axis here, on the positive x-axis, we have 0 degrees, because that's where it starts, right? Now, if we go 90 degrees from this, that, of course, gives you a right angle. It's going to be right here on the positive y-axis. That's 90 degrees up. So you can write that with a box like that. Then if I go 180 degrees, that's going to be a straight angle. That's all the way across, right? This is a straight line, the x-axis. And so a straight angle is all the way across. This is going to be on the negative x-axis. And of course, if you go a little bit further than that, on 90 degrees from that, you're going to get on this negative x-axis here. Sorry, negative y-axis. That's the 270 degree mark going straight down. And finally, I'll just do this one here. This is 270 degrees. And of course, if we go all the way around, that's a full 360 degrees or 2 pi radians. That's back to the positive x-axis. And of course, you can just keep going from there. So you're always going in this circular fashion, right? There's nothing else there. Negative angles, positive angles always move in the counterclockwise direction. So negative angles move in the clockwise direction. So if I get rid of that stuff, and we look at what is negative pi over 2. Well, negative pi over 2 is the same thing as negative 90 degrees. That's going to be right here. This is negative pi over 2, this angle. Because I went clockwise instead of counterclockwise. Now, what positive angle is this the same as? Well, if you go around this way, that you can see is the same thing as 270 degrees, which is the same thing as 3 pi over 2 radians. And these two angles are called coterminal angles. So negative pi over 2 and 3 pi over 2, or negative 90 degrees and 270 degrees, they both end on the exact same line here, the exact same terminal side, if you will. That's why they're called coterminal. They both terminate on the same line. And another one, of course, is if we go all the way around. So let me get rid of this just a little bit, make it a little bit easier. This one, if I just keep going around, so I went around a full 360, and then I went around to the 3 pi over 2 line. That's going to be a total of 630 degrees, or 7 pi over 2. And you can keep doing that, right? You can keep going around. You can go around the other way, right? We can go once around and then back. That's going to be negative, I think, 5 pi over 2, and so on and so forth. There's infinitely many coterminal angles because of the repetitive nature that you can do angles. Now, for negative 75 degrees, let's look at that one. Let's do 5 pi over 3 radians. So pi over 3 radians. So this is pi radians, right? This is halfway across, and then all the way across is going to be 2 pi radians. So if I take pi radians and I cut it into thirds, something like this. It's not exact, but it doesn't have to be. And I can continue it on downwards. So each one of these things is a third. So this is pi over 3, then 2 pi over 3, 3 pi over 3, or pi. 4 pi over 3 is here, which means 5 pi over 3 is right there. This is 5 pi over 3. If I added one more pi over 3, right, I'd get 6 pi over 3, which is the same thing as 2 pi, and that's back on the positive x-axis. What is a coterminal angle? Well, that could be, if you go this way, that's going to be negative pi over 3. And which quadrant is it in? Well, it's in quadrant 4. Okay, and then of course there's infinitely many coterminal angles with that, but negative pi over 3 is just one example. So for negative 75, an angle of negative 75, well, negative 75 is going to be in this quadrant here because this is going to be 90 degrees, negative 90 degrees. And it's less than that, right? So it's going to be somewhere around here. One way of doing that is to get a better estimation. If you cut it in half, you get a negative 45. And 15 can go into 96 times evenly. And 15 times 5 is 75. So if I cut this into thirds and cut this one into thirds, then each one of these angles, this is 15, then 30, then negative 45, negative 60, and then negative 75 is right there. So this angle here is negative 75. I'm just giving you an idea of how to calculate that with some reasonable accuracy. And it wanted a coterminal angle with this. Of course, we can go this way. That would give us the coterminal angle. That would be, what, that would be 270 degrees here. And we know we need 15 more, so 285. You could also go, another 360 degrees around, and that'll get you back there. So it would be negative 360 minus 75. So that'd be another one. You can just keep doing that, whichever way you want to do it. A coterminal angle, like I said, was negative 75, 360 minus 75, or negative the 270 plus 15. It's always it's all the same thing. It's going to be 285 degrees, and it is in quadrant 4 again. Okay, give it a try in number 4. And there are a few special angles and that we will use frequently. And so better knowledge of what they are is going to help you out. The first one is 30 degrees. 30 degrees is equal to pi over 6 radians. The next one here, this one is going to be 45 degrees up to the blue. So I'm going to write this out here on the edge of the line. So this is going to be 45 degrees, which is the same thing as pi over 4. The next one is double 30 degrees. It's going to be 60 degrees, which is the same thing as 2 pi over 6 or pi over 3. Of course, the axes are going to be nice. 90 degrees, pi over 2. This one here is double 60. This is 120, which is 2 pi over 3. Then here we have 45, 90, then 135, which is the same thing as pi over 4, pi over 2. You just add pi over 4, 3 pi over 4. Okay, this one here is 30, 30, that's 60, 30 is 90, 30 is 120, 30 more is on 150 degrees. This is the same thing as 5 pi over 6. And of course, right here on this angle, this is a straight angle, so it's going to be 180 degrees, which is pi radians. And then the same process going down. So each red line increases by 30 from the In this case, it's from the axes. So we had 30, 30, 30, 30, 30, 30. 30 more is 210. 30 more is 240. 30 more is 270. 30 more is 300. Then 330. And finally, 360. So this equals 360. Oops. This is 0, which is 360, which is the same thing as 2 pi, or 0 radians. It's also the same thing. Okay, each blue line is up 45. So we have 45, 90, 135, 180. Up 45 there is going to be 225. Then we get 270. Another 45 is going to be 315. And then back to 0, or 360 degrees. Now all we have to do is add on the pi's, the radians. So each 30 is pi over 6. So we have 6 pi over 6 is here. That's the same thing as pi. Then plus the pi over 6 is 7 pi over 6. Then we have 8 pi over 6, but that's the same thing as 4 pi over 3. Then we have 9 pi over 6, but that's the same thing as 3 pi over 2, which is the same thing as 270 degrees. 3 pi over 2. Plus an additional pi over 6 from 9 pi over 6. That's going to give us 10 pi over 6. That reduces down to 5 pi over 3. And this one's going to be 11 pi over 6. Then we get 12 pi over 6. 12 pi over 6 is just 2 pi when you reduce it. Finally, the 45s. We have pi over 4. Then we have 2 pi over 4, which is pi over 2. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. Same thing as 3 halves pi. 7 pi over 4. And then 8 pi over 4. That's the same thing as 2 pi. And so these are all the special angles. They're really the same angle. It's really just 30, 45, and then 60 with the 90-degree angle here, just rotated in each quadrant. But these are important ones that we're going to be using extensively as we study trigonometry.